इनको tag देते हैं. Hello. Hi everyone. Good evening and welcome back again to Analytics with Anand. Long time. It's been so long. Hope you are doing good. Give me 1 minute before we start. Let me see who all have joined. Just 1 minute. Okay. Is my voice loud and clear? Can you hear me? Can you hear me? Just ping yes, no, if you guys can hear me loud and clear. Okay. Hi, Prem. Hi, everyone. Okay. Okay, my voice is always loud. Okay. Now, in the previous video so far, like after a long time, I'm coming here live because of my office work, then other commitment also. So this is the lecture number 26. Those who have started following these lecture series of Master Blastering SQL Concept on Snowflake. So go through the playlist. Already playlist I have created. Many of you have suggested to create a playlist so that you can follow in a chronological order. Now, when it comes to the joins condition in SQL, I have already discussed your inner join, left join, right outer join, full outer join, and all those things. Cross join and self join was remaining. So this class is entirely on the self join, which you will be using mostly in your data analyst career in and out. Inner join, left outer join, and self join. These are the three joins which is 99.9% used on a daily basis as your data analyst task. First, your inner join, next is your left outer join, third is your full outer join, and fourth one is your self join. Okay, so today's class is specifically on your mastering self join concepts. Now, those who don't know joins, they can refer others video also, but you can join this class because this class has got no relation. Even if you have a zero background of how joins works in SQL, you'll be able to proceed with this class and you'll be able to understand all the things which I'm going to discuss in this class. Okay, all good? Yeah. Let me see who have joined from LinkedIn also. I think I have let you know all at one very short notice. I think that's why maybe most of you might not have aware of this. So please subscribe to my channel if you have not done so. I will try my best to be regular. We have reached 2.5K follower, all because of your support and faith in me. Hi Swati, hi Shivani, hi Fareem from LinkedIn. Shubhaji Sarkar, hi everyone. Good to see you all here. Shivani Bhaskar, hi. Hello everyone. And YouTube also, I am seeing how many participants are joining here, 12. And here also 12. Okay, so I'll begin my today's class from this self-join. Let me share my screen first before we start. Now today's class, particularly join, I will do self-join on mostly on MySQL. The reason I'm not doing it on Snowflake, because as you are aware that Snowflake doesn't enforce your primary key. This is the key thing in the Snowflake cloud, right? Snowflake doesn't enforce your primary key. So it becomes cumbersome in that case, right? Snowflake will allow your duplicate records to get inserted. So that I don't want. That's why I'm explaining you this entire platform on MySQL. You can do it on Snowflake also. You can do, I'll share all the codes via GitHub and you can copy paste the same code on Snowflake. There you can create schemas and everything which I'm going to discuss right now. And then you can try and do. Okay, I will teach you on MySQL first. And then we'll discuss all the business use case which you will do. How from the client requirement, the moment you get a client requirement, how you will come to know that if I need any data, if a client, he or she needs any data, you have to use a self-join. So that we'll discuss in complete domain. Okay, so let me share my screen. 1 second. Sharing my entire screen with you. Okay. Here you go. Let me know if my screen is visible and you can see it very, very clearly. Okay. If everyone can see my screen, right? I'm watching you also on other platforms so that it's clear. Is it clear for you? Now, what do you call this diagram, guys? What can you understand from this diagram? What is the name given to this diagram? You were busy with your marriage. No, I was not busy with my marriage. What is the what is the this diagram you call in relation to data analyst? What do you call this? What do you call this? Huh? Not able to see your comment. Just hold on. Let me enable that in the different laptops so that I can keep a tab. ER diagram. Okay. ER diagram. Now, ER diagram class I have not taken, but I'll make sure I'll take this class for you all also. So that's why I tell you, subscribe to my channel. Everything will be discussed in SQL. Not a single topic will be left. Okay. Not a single topic will be left. So I'll discuss this in the separate class. Now, this is the diagram. Do you think this is provided by the client or it's us as a data analyst that we created? What is the point on this? This diagram is given by the client or it's us, those who create this? Like, I mean, this is the job of a data analyst. What do you think? Who creates this ER diagram? Open my... Huh? Who creates this? Who creates this diagram? Sometimes there might be chances that this is given from your consultant, from your business requirement, or there can be a scenario where consultant is asking you this. Consultant is asking you this, right? So from this diagram, can you make out, can you understand what all things are going in here? I will explain you in this class. I will explain you in this class what all things are going here. Okay, so this is the ER diagram. How many columns you can see here? How many columns you can see here? How many columns you can see here? Okay, so here we see the two schemas. Here we see the two schemas. One is called the sales schemas, one is called the production schemas. Make sure these are not table. Sales and productions are your schemas. And you must be aware what is schemas, what is table, what is warehouse. Already I have discussed in my previous class, right? Already these things I have discussed in my previous class. So these are schemas. Okay. Now we have two schemas. One is sales, one is production. Right. Now in the sales schemas, how many tables you can see? Customer, staff, order, store, order items. Right. These are the tables. And in production, what you can see? Category, products, stocks, and brands. Right. Correct. These are the diagrams. How do you create this ER diagram? That is entirely a different story, which I'll discuss in the next class. And what are these lines means? I don't want to discuss that in this particular class because this class is specifically catering to the self-join requirement. Okay. So as you can see the diagram, I'll just explain you the diagram. The bike store sample database has two schemas, sales and production, and these schemas have 9 tables. Count the table: 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? This is the table structure which is given to you. Now let's describe sales.store. What does sales.store table contain? Sales.store, store ID, store name, phone, email, street, city, state, zip code, right? Similarly, order will have order ID, customer ID, order status, order date, required date, ship date, store ID, staff ID. Similarly, customer will have all the customer name, right? Basics details, phone, email, street address, right? Staff ID, first name, store ID. Every staff will belong to certain store and every staff will have certain manager ID, right? Like every employee reports to your manager and manager is also an employee. Okay. Similarly, you have order items, order ID, item ID, product ID, quantity, list price, and discount. This is for the sales schema. Next comes your production schema. Production, what you have? Category, because there can be different product category, right? Category ID, category name. Then you have the different product table where you'll be having product ID, product name, brand ID, category ID, model year. Then you have the stocks, store ID, product ID, quantity, and you have the brand. This is the real thing which you will see as a data analyst exactly in the same domain. Right? You will have a sales schema, you'll have a production schema, and this you will be interacting with total 9 tables. Okay. In reality, you will be joining with like 10 tables. I have written join condition with 10 tables. Not beyond that, you won't exceed beyond 10 tables. Right. So I have kept 9 tables. I wanted to explain you from the complete angle, not with 2 or 3 tables, or not with the basics joins and all. No, it has to be complex. Until and unless you understand how IT industry works, you won't be able to grasp these concepts. right? So this is all the things. I'm not going into this detail describing a table. I will share with you. I will just read the script for you. Everyone knows already this has been discussed. Sales store ID is there. Identity 1,1. Already I have discussed this. What is identity mean? Identity means auto increment. Automatically every store ID will get incremented. 1, 2, 3, 4. This has been discussed in great detail. I will add that. I will add the video description in the comment. You can watch this also. How identity and auto increment works in Snowflake and MySQL. So this is the one. Right, primary key is the store ID. Of course, store hai to store ID hi hoga primary key. Phone number, where, care. Everyone is aware of this, right? Already have discussed this in great detail. Then you will have staff ID. Staff ID, staff ID hoga, which will be unique. Again, staff ID, I'm taking 1, 2, 3, 4, 5, 6, like that, and other details. Right now, in your staff table, there's a foreign key called store ID, because store ID is also mapping to some another table. Foreign key, primary key concept also have been discussed in great detail, right? And it is referencing which store ID? Store ID is there in the staff, which is pointing to sales.store of store ID, right? And for that, we are creating a reference, primary key, right? We are creating a reference, which is mapping two primary key being mapped to each other. On delete cascade, on update cascade. This also I'll take a different in a separate section, but I'm explaining you now. On delete cascade, on update cascade means if any child table you are deleting it, or if you're deleting any records from the parent table, automatically records from the child table will get deleted. Okay, from the timing, understand this. Say for example, if any amount is getting deducted from your dad's account and he's giving you every month pocket money, so your pocket money will get reduced because you are dependent on him, right? You are dependent on him. In that way it works. I will discuss this in a separate section, so don't worry about all of this. These two I will discuss in a separate section. Okay, then you have the category ID, you have a primary key, category name, then you have a separate brands, then you have a products with all the product ID, product name, brand ID, category ID, model year, list price. Again, your production products has a foreign key called category ID, which is mapping to production category ID. Same foreign key, I have taken a brand ID. Then you have a customer details, same thing, exactly on the similar fashion. Then you have orders, same order details. This is the status, one pending, processing, rejected, and completed, right? And again, this also has customer ID referencing. Okay, this also has a foreign key. Then you have an order items listing all the order details. Not null constraint, discount cannot be null, and default discount I'm giving it as 0. So this is just a table overview, right? This is just a table overview. Production stocks, it has primary key too. Can I apply on 2 columns? Yes, I can apply primary key on 2 columns. This is called a composite primary key, right? Primary key can be applied on 2 columns, store ID and product ID. Combination of both can exist, which is called composite primary key, right? Many times in reality, you will see one primary key, but things might change, right? We can have 2 primary key also. There can be a case, and this is the case which you are seeing it here. So this kind of table, I want all of you to practice joins in such a way. Don't practice, guys, joins on 2 or 3 table. No, I need minimum of 5 table for you all to practice, whether you are practicing inner join, left outer join, right outer join, self join, cross join. Until unless you take 5 table, you won't be able to understand the joins concept into the picture. Now let's come to the agenda of today. SQL Server self-join syntax. Now, the first most important point, how you will come to know that whether I have to apply self-join if the client gives you any requirement. If the client gives you a requirement, let me reiterate this fact, or whether I need a self-join, or whether I need inner join, left join, or right outer join. If my requirement involves only one table, and you need to compare rows means records, right? In data analyst, your rows means records and your column means fields or attributes, right? We call rows as records and columns we call field, attributes, and in machine learning we call features, right? Anything you call features, you call attributes, you call field, you call, or you can also call columns, but mostly we use attributes or field. Okay, so if you need to compare between two rows, say for example, I will give you a very realistic use case. Say we all work in IT industry, right? We all report to our manager. Even manager reports to senior manager reports to VP reports to CEO, right? So I'm having only one table called employee. Now in employee ID will be there. Manager will also be an employee. So manager will also be there. So manager will have a manager ID. Employee will have an employee ID. Now every employee will report to any manager. Every employee will report to some manager, right? Every employee will report to some manager. Now I want to know I want to know which all employee is reporting to which all manager. Now, what you're doing, you are comparing between two rows, right? First row can be an employee, second row can be a manager, because manager is also an employee. Now, when you have such scenario, right? Or the next, another example, I'll give you. How many of the employee belongs to the same city? How many of the employee belong to same city? What you will do? You will compare the rows where city name is equal, right? You will compare the rows. But these all information are present in just single table. I am not joining with another table. That's why the name has called self join. When you have only one table in hand, when you are not joining two tables, because only one table is there, and you need the information from one table, at that place you will go with the concept of self join. The self join allows you to join a table to itself. It helps query hierarchical data or compare rows within the same table. This is very, very important concept, right? So there is no syntax wise, you don't have to write the word self. You can write either use inner join, or also you can use left join within a self join. I'll explain you how. Because the query that uses the self join references the same table. The table alias is used to assign different name to the same table with the same query. Now you will say, sir, when you join two table, you take two alias. Now, yeah, here's only one table is there. So what are the alias you will take? You will take the two pointers. Imagine a tank is there. Tank is a table, and you are taking two pipes to fill the tank. Of course, so these two pipes, pipe 1 and pipe 2, are called alias, which is pointing to the same table, right? Same table. So this is the syntax which you need to follow. Select any list, select the list of columns, whatever the columns list you want. From table T1 is the alias. You can use inner join, left join. You are aware with this, where to use inner join, where to use left join. Same table T1 and T2 are the two alias. And on join predicate. What is this join predicate? Join condition. On what basis you need to join this? On what basis you need to join this? Okay. Let me explain you a very simple example. Then I will go to this bike store example. Let me open my Snowflake first. Let me see if I have the data here. 1 second. Let me check 1 minute. Sorry, my bad. Let me log in quickly. 1 second, just hold on. So I am creating, know the syntax. Use database, demo database. I'm using it. I'm running it. Then I'm creating this table, AJ employee raw. Okay. Then I'm inserting the data. Done. Okay. Let's see whether the data is there or not. Yeah, data is there. Let's talk about agents table. Let me run this. Let's talk about values. Let me create a customer table. I'm not explaining this all code. You guys are aware of all this. Already this has been discussed in the separate classes already. You can follow my any of the lecture videos. In the playlist, you will find all this. Then I'm finding the sales. Then I'm inserting the values into the sales. I'm showing with you first of all 3 tables. Now, okay, let's see the sales table. Okay. So sales has ID, house ID, see date, agent first name, agent last name, customer ID, and price. Which sales agent has served which customer? Customer ID 14, 12, 13, 15, 15, 11. Like that. Now, what I need from you is listen this code. Okay, let me explain you this code. What this code is doing. Now, I have only one table agents A1 and A2, right? I am having only one table agents and A2. Okay, I will edit this. Let me run this and show it to you what exactly this is doing. Then I will explain you the self join. What it is doing. Agent 1 first name, agent 1 last name. Okay. Kate White. Agent 1 experience 5 years. Agent 2 first name, agent 2 last name, and agent 2 experience. Okay. Same table I'm using. Now listen. Okay. So select. Forget about this. Never see the select requirement. Okay. इसको भूल जाओ. 2 table from agent A1 join agent A2. You can also use the word inner join. If you don't use the word inner, by default it means join. From agents A1, inner join agents A2. Okay, inner join agent A2. On A1.id, let me write not equals to A2.id. What exactly, sir, you are doing it here? I am comparing rows because ID will be unique. I am comparing ID1 with ID2. I am comparing ID1 with ID2. Oh, sorry. ID1 with ID2. Okay. I'm writing not equal to. What will happen if I write equal to? First of all, what will happen equal to? Can ID be equal? Agent 1 ID and agent 2 ID will be equal. Let's run this and try to understand first. Let's run this and try to understand first. यहाँ क्या दे रहा है? Kate White, Melissa Brown. Sir, you are giving me the duplicates. Of course, you are giving me the duplicates. Same pointer, you are pointing to the same table and you are comparing the ID. And you are comparing the ID. So, of course, it is coming from the same table. So, it will give you the duplicate records. Kate White, Melissa Brown, Alexander Moret, Sophia Scott, Stephen Black, Mary Scott. That's not my requirement. That's not my requirement. I want where ID is not equal. ID is not equal. Agent first name, agent last name, agent experience. Now, why I have taken agent 2 first name, agent 2 last name, and agent 2 experience? I want to assign agent 1 with agent 2. What exactly I'm doing? Suppose you are joining any company, you will be given a mentor, right? You will be mentee and you will be given mentor. So everyone, those who joins company in a fresher will be given a mentor. So I want to club my mentor whose experience is having more than 3 years with my mentee whose experience is having less than 1. Why I have given less than 1? Because he or she is a fresher. I want to club them. And both are employee, both belongs to the agent tables. For example, I'm not using 2 tables. Then in that case, your self-join concepts come into picture. Let me run this and showcase it to you what we are having it. Kate, Stephen, Kate White, Stephen Black. Kate White, Stephen Black, Kate White, Maria Scott, right? Then Sophia Scott, Stephen Black. Correct? You're getting Sophia Scott and Maria Scott. Sophia Scott and Maria Scott. Why I have given this not equal to? Why I have given this not equal to? Because their ID should not match. I'm not clubbing on them ID. ID should not be equal to because I'm comparing rows. I'm comparing rows. And what is the condition? I want my mentor, those who are mentor, those who will be mentoring his or her mentee should have experience more than 3, and the mentee, those who have joined the company as a fresher having experience 1. Which are those combination? Where this combination existing? So this is the combination. So Kate White, agent 1. What was the agent 1? Agent 1 is the mentor. Agent 1 is the mentor. Let me write this. Agent 1 is your mentor. This is mentor. This is mentor and this is mentee. You can see age experience mentee. So both are matched. So Kate White is a mentor and mentee is Stephen Black. Right? Sophia Scott is a mentor and mentee is Stephen Black. Okay? Sophia Scott is a mentor and Maria Scott. That means Sophia has 2 mentees. It can happen, no? One manager can point to two different mentee can have. Right? Every manager case takes us to certain number of people inside it. Like we report to manager, right? So not only I reporting to my manager, there can be other candidate also who reports to manager. So in that case, Alexander McGraw reports to Stephen Black, right? No, sorry, Stephen Black reports to Alexander McGraw and Maria Scott. Okay, so in that case. But tell me one thing. What is the issue here? Maria Scott is reporting to Alexander McGregor. And again, Maria Scott is also reporting to Sophia Scott. How is that possible? What wrong did I did in the query? Maria Scott is reporting to Sophia Scott also. And Maria Scott is reporting to Alexander McGregor. How can one candidate be reports to 2 different? Here in this case, it may happen. I don't know. Here in this case, maybe the data is like that because we are discussing agent. We are not discussing the employee details. Right? Here in this case, by checking the data, it may happen that one mentee is reporting to multiple mentor. One agent 2 is getting clubbed with agent 1. That means this agent is also reporting to this, and this agent is also reporting to this. This may happen, I'm telling you. This may happen. So in order to avoid this ambiguity, let me show you one thing. Agar if I do this, less than. How will the output change? How will the output change? Now, what is this? Still the output is same. Check. Sophia Scott, Maria Scott. And again, Maria Scott, Alexander Scott. Yes, it remains the same. Right? Kate White, Stephen Black, Kate White, Maria Scott. Okay? Kate White, Maria Scott, and then, sorry, Sophia Scott, and then Maria Scott also reporting. Right? So you should use this condition very, very wisely. I will discuss the 3 use case, where to use not equal to, where to use less than, and where to use greater than. You should never use not equal to. Why? I will explain you using bike store example. You should never use not equal to. You should always use when you are comparing rows either less than or greater than. Why? Just wait for 10 minutes. Just wait for 10 minutes. Anyone, those who knows why we should not use not equal to, why we should use less than or greater than? Who can tell me this concept? Why you should not use not equal to? Why you should not use not equal to? Huh? Why you should not use not equal to? Why less than or greater than? Any one of you? Those who knows this concept? Where to use not equal to, where to use less than, where to use greater than? Let me show you in MySQL also. Just give me 1 minute. I'll show you. Just hold on. Let me quickly create. You can able to see my screen, right? I'll zoom a bit. So I'm creating a table student. I'm creating a table student. I'm inserting the values. Okay. Correct. Student ID, course ID, course duration. Student ID, course ID, store duration. What I'm doing it here? What I'm doing it here? Select distinct S1.student ID, S1.name from student as S1, student S2, where S1.student ID equals to S2. All those students which belongs to what exactly this is doing. See the statement again. Adam, Shane, and Peter. Remember, Adam has 2 cores. Course ID 1, course ID 2. Course ID 1, course ID 2. Peter has course ID 2, and Brian has course ID 3. Shane has course ID 3. So if I run this code, select distinct student ID, name from student as S1, student S2. I have taken 2 alias for student S1 and S2, where S1.student ID. Now you will say, sir, why you are taking ID as both? Because I need the list of that student who have taken, what is this? S1.course ID is not equal to S2.course ID. The course ID is different, not same. So it will give you Adam, Brian, and Peter. Run this code, you will get the same thing. What I'm saying. Adam, Shane, and Peter. Okay. I'm discussing only on one table. There's no concept of 2 tables. Self-join will come into picture only when you need to compare rows in one table only. In one table only. Right? Either you can do this or you can do this. Both are same, guys. There's no issue at all. Either you can use this or you can use the word inner join also. Because I'm joining the same table. Right? Joining the same table. Okay. S1.student ID, S1.student, and course ID should not be different. Course ID should be same. Let's see from the percent points. Let's see from the percent point. I'm giving you all the realistic use case. Let's see from the percent points. Now, list of employees who reports to the same manager. This is very, very nice. List of employees who reports to the same manager. See this. List of employees, those who reports to the same manager. Right? Like Anand Jha, data analyst, salary. So Anand Jha reports to 8. Who all reports to the same manager? Say, for example, fix 8. Anand reports to 8. Chaturvedi reports to 8. And who reports to 8? Only 2 managers report to 8. Who reports to 10? Mishram reports to 10. Yadav reports to 10. And M also reports to 10. Okay, so I want to know the list of employee. List of employee, those who reports to the same manager. Those who reports to the same manager. So here the concept of self-joins comes into picture, because you need to compare rows. You are comparing rows, right? You are checking whether this is same or not. When you compare rows, the best part you can use is you can use the self-join. You can also use the same concept by window function also, using partition. Using window function row number also you can use it. That I will discuss in the separate class. Okay, so let's see what is the code which we need to write. Select distinct p1.person ID as employee ID. I'm concatenating first name and last name as employee full name. p2.reports to manager ID from persons p1, persons p2, where p1.person ID not equals to, because manager and employee cannot have the same ID, right? So this is very, very important. Not equals to, and p1.reports to is equals to p2.reports to. Both should report the same one. Reports to is the column, no? I'm comparing rows. Guys, got it? I am comparing rows. That's the beauty of self-join. I'm comparing rows, whether this is matching or not. If that is matching, that means my self-join I have achieved, and I will give the list of all the employees, those who reports to the same manager. Those who reports the same manager. Right? Those who report the same manager. So Anand and Chaturvedi reports to manager number 8. Vineet, Abhishek, Sagita, and Agita reports to manager number 10. Getting my point? You will compare rows. So in that case, you will use the self-join. Okay? Getting my point? No, group by one. How group by will work? How group by will work, Shri Prasad? You tell me. How group by will work here? How group by will work? How group by will work here? कैसे करोगे group by से? Group by is an aggregate function. Group by is an aggregate function. Did I use minimum, maximum? Did I use count? Nowhere have I used the word count. Did I use average, maximum, minimum? No, no, no. I didn't use it. Right? I didn't use it. Next, list of all reporting managers, the number of employees. What about this? I'm taking count. Count. Manager ID 8. How many total employees reporting? 2. Manager ID 10. How many total employees reporting? 4. Now you will use aggregate function only when there's a mathematic function involved. Aggregate function. Count. What I'm doing? Distinct p2.reports to. p2.reports to as manager ID. Count concat distinct p1.person ID is total employee reporting. I need a count of p1.person ID from person as p1, p2. Person ID should not match, guys. And p1.reports to should equals to p2.reports to. Person ID should not match. Person ID should not match. Okay. Person ID should not match. Getting my point? Getting my point? Getting my point? Okay. So here I need a count. Here I need a count. Now I need list of all the employee and their associated managers. Again, self-join, because there is only one column involved. There's only one table involved. There's only one table involved. Now here in self-join, your join condition becomes very, very important. You should not write a1.person ID equals to b.person ID. Nahi, ye galat hai. ID we are not matching. We are what we are matching. Person ID who reports to report ID. Right? I need reports to ID. That should match. I am reporting to X manager. You are reporting to X manager. So reports to should match. This is very, very important. Sometimes we in the interview from freshers we ask this. What is the condition you will be writing? What is the condition you will be writing? An order by manager. Right? An order by manager. Correct? Getting my point? And I want the list of all the manager person who is reporting to the employee having count, total employee reporting more than 2. This is a very realistic use case, HR analytics, right? So these are the 2 managers and total employee reporting them and 4 and 2. Successive row salary comparison. You can also compare salary. You can also compare salary. Whose salary is more, whose salary is less. Whose salary is more, whose salary is more. See this. Compare salary from where p1.salary less than p2.salary. Same table, but you are doing comparison between rows. Same table, but you are doing comparison between rows. When there's the same table and you are comparing between two different rows, then you will go with this condition. p1.salary less than p2.salary. Okay. p1.salary less than p2.salary. Now, let me come to the bike store example. The most important part. Let me come to the bike store example. So this is the bike store. I have created all this. I've inserted the values, right? I will share the script with you. You can execute, right? I have master table creation. I have taught you this concept also. This is the master table creation. How do you convert master table creation, right? 1 minute. Use byte store. Once again. Now it will work. Master table creation also have taught you how you can create the master table, right? Everything I have created. Okay. Now, who reports to whom? I told you self-joining the following query. Who reports to whom? This, so we have seen this, right? Now, tell me I want the list of all employees, those who belongs to the same city. Hot favorite interview question. List of all employees, those who belongs to the same city. Only one table is there. You need to compare their city. What is the join condition? I want from all of you. What should be the join condition? Who belong to the same city? What you will compare? What has to be equal? What not has to be equal? Right? Your ID should not be equal, but your city has to be equal. This is the join condition you will be working on. Your ID should not be equal. Your ID should not be equal, but your city should be equal. You will say, sir, why you have given greater than, why you have given not equal to? Let's give not equal to and try to see. Let's give not equal to and try to see. Sorry, what happened? एक second देखूं मैं. एक मिनट, क्या एरर कर दिया भाई? अच्छा, sorry. Listen, I've given not equal to, which belongs to the same city. ठीक है? Douglas, McGray, Prince Williams, McGray, Douglas. Now, the reason you should not give not equal to is very, very important. Never use this into your code when you are doing search. Why, I'll tell you. Say, I'm handshaking with you. I'm handshaking with you. Does it counted 1 or 2? Will it be counted 1 or 2? I'm handshaking with you. You are handshaking with me. Is it same or different? Huh? Is it same or different? Tell me that. Quick. I need it in the chat. I need it in the chat. If I am doing handshake with you, you are doing handshake with me. Is it same or different? It's same. See. Say, for example, me and David belongs to Bangalore, or me or Shiv Prasad belongs to Bangalore. I and Shiv Prasad belongs to Bangalore. So if I have this record, why again record has to exist for Shiv Prasad and Anand? Why record has to exist for Shiv Prasad and Anand? If already one record is there, if Anand has done a handshake, if Douglas has done a handshake with McGray and Gray has done a handshake with Douglas, both are same. So this will give you duplicates. Although this is not a duplicate, but this is duplicate. This is ambiguous. This is not your efficient code. This is not your efficient code, right? This is not your efficient code. It is giving you duplicate. Never ever use not equal to. Rather than you should use less than or greater than, so that you can avoid this ambiguity. That's one thing, so that you can avoid this ambiguity. Okay, so that you can avoid this ambiguity. Just give me 1 minute, guys. Guys, you should never ever use not equal to. This was the reason I was trying to explain. Now see what will happen if I do less than. You can use less than or greater than. Less than means you are comparing first with second. Greater than means second you are comparing with first. That's the difference. See this. Now your duplicate will be gone. 1 minute. Now you won't see any duplicate. Okay, McGray, Douglas, McGray is not there. Douglas and McGray is not there. See, Douglas and McGray is not there. Only McGray and Douglas is there. Right? It will sort in descending or ascending. Which is taking? It will sort in descending or ascending. Right? You can use greater than also, and you can see the output. Right? Which one is it taking? Which one it is taking? Which one it is taking? See, Douglas is there. So use greater than. If you want your result to be sorted in ascending order, use greater than. Less than will give you in descending order. Okay, now there won't be a record. Douglas and McGray and Douglas won't come. You can check also. McGray and Douglas won't came into picture, right? McGray and Douglas won't come into the picture. So never ever use not. I have seen many students doing mistake. They're using this. No, you should not use this, right? Unnecessary, it will create an overhead on DB, on database. Client has to pay more. Think about 10 million records. Suppose you have 1,000 such records. How much you are getting? 1,000 into 2,000 records, and that will take more time to execute. And the Snowflake has cost associated with it. Every query you execute, you have to pay. So bear this. Never ever include not equal to. If in that such case, when you are comparing, you will get duplicates. I hope I'm making sense. That's why I discussed this topic, self-join. Most students do mistake here. Same city, what is the code? C1.city, C2.city. Why it has to be same? It has to be same because I need the list of all employees, those who belongs to the same city, right? And what about the ID? ID should not be equal to that. I know, but you should not use not equal to because it is the same table, right? I am doing handshake with you. You are doing handshake with me. 2 records will come, but that is wrong. And if I and you belongs to the Bangalore, why it has to come? Anand and Shrey belong. Shrey and Anand Bangalore. No, it's done. Anand and Shrey Bangalore. That is Bangalore. Right? Getting my point? So you should always use either less than if you want to short in ascending order, greater than will give you in descending order of the name, whichever you are using. Whichever you are using it. Okay? Clear? Getting my point? So less than will give you in descending order. See, A, B, C, D, F, G, H, I, J, K, L, M. Okay. So use one among them. Give the city name and the count of all those who belongs to the same city. I can have the count also. I can have the count also. So in this case, self-join is not required. In this case, self-join is required. Give the city name and the count of all those who belongs to the same city. Count of all those who belongs to the same city. No. In this case, the self-join is not required. Why? You need a count. Who belongs to the same city. This you can use group by. I think Shiv Prasad, you were asking this. When you need a count who belongs to the same city, understand my question. Then in that case, no joins is required. Many a times you can solve business problem without using joins at all. Think and do accordingly. Is it clear or not? Huh? Is it clear or not? Okay, let's talk about the bike store example. Okay, let's talk about the bikes example. Consider the following staff table from the bike store. Staff ID, first name, last name, email, phone, active store ID, manager ID you have. The staff table stores the staff information such as ID, first name, last name, and email. It also has a column named manager ID that specifies the direct manager. For example, Miria reports to Fabiola because the manager of Miria is Fabiola. है ना? Miria किसको report करती है? Fabiola. Manager ID 1. What does null means? Null means top manager. Null means top manager. CO1. Null means top manager. CO. CO किसी को report नहीं करता ना? CO तो independent है. ठीक है? That's what the null means here. Okay? Okay. Fabiola has no manager, so the manager ID is null. To get who reports to whom, you can use the self-join. There's no other way which you can do this. Who reports to whom, you can use self-join. Self-join, what is the join condition? Staff ID should be equals to manager ID. That's what I have explained to you. Your staff ID should be equals to manager ID. Right? Same table. That's why 2 pointer you will use. Pointer number 1, pointer number 2. Wherever these two are equal, I will get who reports to. Who reports to whom. Getting my point? When you're comparing 2 different rows. When you're comparing 2 different rows, then in that case. When you're comparing 2 different rows, then in that case, you can go ahead with this. Okay? Simple. See this? Right? Getting my point? Now, I can use left join also. If I use left join, I have told you guys, left join will give the list of all the employees, whether or not they report to the manager or not. That's the beauty of left join. That's why for Fabiola, you will see null. But if you take inner here, you won't see Fabiola here. Because Fabiola doesn't report to any manager. That's the beauty of left join and your this one. Inner join inside a self join. We never use the word self. Don't worry. We'll never use the word self. We use using inner join. Same self join means one table. Self join means one table. Just 2 different aliases there. Just 2 different alias, and you are good to go. E.staff M.staff ID equals to E.manager ID. You'll get it. Just use inner join, left join. 3 most widely used joins in the business use case: inner join, left join, self join, and one more is full outer join. We use it. Okay. If you have mastered this, you can do this easily. You can do this easily. Same city, this I already have explained you. This already have explained you. He belongs to the same city. C1.customer ID greater than C2.customer ID. Those customer ID which is more, I mean next in the row in descending order, then in that case you will be using this. But city has to be same. Don't use not equal to. No, I don't rely on that. No, don't use. That's not a very good way of writing it. Don't use not equals to, right? Otherwise, you'll get two different records. Okay, don't use not equals to. Okay, no, don't use not equals to. If you change the greater than operator by not equal to, you will get more rows. You will get more rows. That's what I was saying. You never ever use. See this? It's like a duplicate. It's like a duplicate. Can you see this? Why you want this duplicates? This report to this report to this are duplicate, no? So you should not do that. You should not do that. That's why see here also duplicate. So many records. Journal and Andrea and Johnny. Only one I should get that. That's the beauty of less than and greater than. Less than will give you the recording ascending order. Douglas, D will come in the customer one. Greater than will give you the ascending order. J will come at the first. That's the beauty. Okay. In the interview, they will ask you, Anand, is this all same? These all are same, except this. All will give similar result, not same result. You should not use this because you will get duplicate records. Give the handshaking example. Give the employee example. There's so many examples which you can give. Okay. Right? Not equal to, you should not use. See, Albany, how many? You can check also where C1.city equals to Albany. You check. See this. If I check for city Albany, why you need only two customers are there? Now Douglas, McGray, Douglas, and McGray, Princia, Douglas. Again Douglas, Princia. Unnecessary you are having duplicates, no? Instead of 3, you are getting 5 records or 6 records. Instead of 3 or 4, you are getting 5 records. Right? That's why you should avoid using not equal to. That's all in the self-join. Beyond this, nothing will be asked in your interview. This is more than enough. And if you want to practice all your joins, this is the best data set which I'm sharing with you all. Bike Store. This is really, really good data sets which you can practice so many joins, so many information you can have from it. Right? I will share you the entire code, just practice. And this will be enough for your self-join. Beyond this, interview won't be asking you a single question apart from the self-join. Right? Whenever interviewer will give you any question which involves only one table and you need to compare rows, immediately tell self-join and use less than or equal to, less than or greater than. Never ever use not equal to. Okay, I hope I am making sense. And always practice on 3, 4 table. Don't practice on one table. Practice 3, 4, 5 table. Join it, make it as complex as possible, and then you practice it so that it will help you in the longer run. Okay, that was all from my side. Super fast self-join. I have given you the explanation. Go through the video at your own pace. If you have any doubt, comment in the video only. Comment in the video only, and I will be able to reply on that. And I will be able to reply on that. Okay. Clear? If you have any question, feel free to ask. Okay. Getting my point? So that's all in the self-join. Okay. See you then in the next class with the new join. Cross join is left and full outer join is also left. City is left. Stored procedure is left. There's still many things. And then once the SQL gets over, your Snowflake gets over, at the end we'll do one master project on SQL live. Okay. That day I'll come a little bit early so that we can focus end to end. But there are so many things. City is there, subquery is there, and then again more things will come into picture. It's a very simple concept. Only one table, and when you want to compare hierarchical data between 2 different rows, whether they belong to the same city, whether they have purchased the same product, right? Correct? List of all the employees, those who have purchased the same product. List of all the candidates, those who bought the same course. List of all the employees, those who got the same gift. List of all the employees, those who got the same hike. So many realistic examples. List of all the Amazon, list of all the products from the list of all the customers from Flipkart or Amazon who have ordered iPhone in the same month. You're comparing rows of the transaction, self-join. कितने सारे realistic use case हैं. List of all the customers from the banking domain, those who have taken a home loan in the same month. So many things you can do using cell join when you need to compare the rows, right? Then in that case, but use your join condition very, very effectively. Use your join condition very, very effectively. Either use less than or greater than. Don't use not equal to until unless it is required, right? When you have two different conditions. When you have two different conditions on joins predicate, whether they belong to the same city, whether they have taken a loan in the same month, when you are comparing two employees, whether they have taken the loan in the same month, use less than or greater than. Don't use this. Okay, then it will be compared. I have taken the same loan, you have taken the same loan, you have taken the same loan, I have taken the same loan. It will count as duplicates. Don't use that. Keep this thing in mind. Always use less than or greater than. That's and equal to, of course, wherever is the case. Done. Should I wrap up? I don't want to drag it much. Whatever was the agenda was there set for the today, I hope I have made sense. If you have any doubt, feel free to ask me. Any doubt if you have. Or if you don't have doubt, just we can wrap up. Okay, shall we end the class? Next topic we'll discuss full outer join and other cross join, whichever is pending. Joins, you need to master it very, very effectively. Practice these data sets. I will share in my GitHub link. It will be there in the video description. After the end of this visual report, all the code, just you practice it in the Snowflake, you practice it in SQL. Right? Guys, I am teaching you on Snowflake. I'm not teaching you on MySQL. Code-wise, it remains the same. 99% of the time, it will remain the same. Copy paste the same code in MySQL and try to do it. Okay, that's the reason I started this on Snowflake particularly. Same bike store example, which I have given you this code, which I will give you this code. Run the entire code in your, create the schema, create the table in your Snowflake, execute it, create a master table, and practice all the joins concepts, whatever you can. I will give you the list of all these questions. Okay, I'll give you the list of all these questions. Basic sequels also have covered. This is a very good example. Those who are very fresher, those who are very new in this data analyst domain, this is the starting point, right? This data sets will give you confidence, that boost that at least you will have. Yeah, you can run on MySQL, Ashwarya. Okay. I need to start with Power BI classes also. Python also I need to start. So I'll make sure that I'm active on this channel as much as possible. Because of office and other commitment, I feel it's very hard, no? Plus 10 o'clock, because sometimes my work gets over 9:30, and it's not easy, no? Right? To come live, I need to prepare all this. I cannot simply just jump and then, okay, chalo, let's start the class. No, I have to prepare these data sets. I have to prepare the DB. I have to see whether any syntax error is coming or not. Everything is neat and clean. I have the PPT ready or not. So it takes time, effort, and energy. That's the reason I avoid usually if I'm not ready. Because it doesn't make sense if I don't add value to this lecture, right? So this is the lecture number 26. I have told you total 40 lectures will be taken in Snowflake. Yeah, in 40 lectures, your SQL will get over. 2 more lectures, joins will get over. Then CT will come. CT already I have discussed. Part 1, part 2 I will discuss. Subquery I have discussed. In part 2, CT I will be discussing. Okay? Okay. Good night. Signing off. Bye-bye. It was lovely coming here after a very long time. Feel free to subscribe this channel if you have not done. Spread the word. And I would need your suggestion also. What all you want me to teach after this. Whether you want me to start with Tableau, Power BI, Python, or whatever. Okay? But this Snowflake gets over. Then. Bye-bye, guys. See you then. Good night.